we're going to do a quick review of factoring and your thought process as you're approaching a factoring problem. So we're starting off with a factoring flowchart here, and the first thing we come to is the greatest common factor. So anytime you're looking at an expression that you are trying to factor, you would try to determine if it has a GCF. For example, if we had 5x minus 25x squared, this does have a GCF. And so what we would do first is factor out that greatest common factor. So in this case, the greatest common factor is 5x, and that would leave us with 1 minus 5x. Now, if it does not have a GCF, you'd go straight to how many terms does it have. This is what you're thinking, but if it does have a GCF, you would always want to factor out the greatest common factor first. Then we look at how many terms. If it has 4 or more terms, we're going to try to factor by grouping. And I'll show you that in just a moment. If we had an expression such as this one. Let's say we had 21 x to the third. And then we had plus 6x squared plus 7x plus 2. This is a 4-term expression, and we would look at the first 2 terms. We would pair them and see if they had anything in common. And we do see that the first 2 terms here do have a common factor of 3x squared. And when we factor that out, we are left with 7x plus 2. And then we look at our second pair of terms, and we see that if we factored out just a positive 1, we would be left with 7x plus 2. So this factors to 7x plus 2. This is the factor that both terms have in common, and then we group what's left, which is 3x squared plus 1. So that's an example of factoring by grouping, and we can use them in a lot of different ways. Now, if we didn't have 4 or more, let's check and see, do we have 2 terms? If we have 2 terms, we're going to look to see if we have a difference of squares. If we have a difference of squares, then our approach would be this. A difference of squares is where we have a term squared minus a term squared, and that factors to the square root plus the square root and the square root minus the square root. For example, we might have 16a squared minus 25b to the 4th. Okay, or it could even be b to the 6th. Let's change that. So my first term is a perfect square. My last term is a perfect square. It's anything that I can write as a term squared. So 16 is 4a squared, and 25b to the 6th is 5b to the 3rd squared. So this, in fact, is a difference of squares, and it factors to that square root plus the square root times the square root minus the square root. Okay, if we do not have squares, maybe we have cubes. We could do a sum or a difference of cubes. And this is where your teacher may have used the mnemonic SOAP, and the SOAP mnemonic represented same, opposite, always, positive. Okay? And all that means is your signs, if this is a sum, same, opposite, always positive. If it's a difference, same, opposite, always positive. That helps you with your signs. So these are sums and differences of cubes. So if you notice, you have 2 terms, and it's either a sum or a difference of cubes. Both of these work the same way. For example, let's say we had x cubed plus 8. So this is a sum of cubes. So my signs would be same, opposite, always positive. The cubed root is x, the cubed root is 2. So we do the cubed root of the first term, the cubed root of the second term. Then we square this x. We do the product of the two. This is our AB. And then we square the last. Okay? Let me give you another example, and I'll give you one with subtraction. Let's say we have 64a to the 6th minus 27b to the 12th. Okay, so both of these are perfect cubes, and this is subtraction. Our signs would be same, opposite, always positive. The cubed root of 64a to the 6th would give us 4a squared. The cubed root of 27b to the 12th would be 3b to the 4th. Okay, and then we would square that first term. 4a squared squared would be 16a to the 4th. The product of the two, 12a squared b to the 4th, and square the last, 9b to the 8th. And that is a sum and a difference of cubes. Now, do we have a sum of squares? Well, a sum of squares is not factorable over the set of integers. So if you have a sum of squares, so if we had something like 16x squared plus 25, this is not factorable over the set of integers. So we would move on. All right, the other option was 3 terms. And when we have 3 terms, you might want to check to see if you have a perfect square trinomial, such as x squared plus 8x plus 16. If I see a perfect square and a perfect square, I'm always going to try to write it as a binomial squared. Square root of the first term, square root of the last term, sign of the middle, and I must double this product to check and see if it is a perfect square trinomial. So I double the 4x, I get 8x, so yes, that works. Okay? All right. If we were not working with a perfect square trinomial, is the leading coefficient 1? If it is, this is really easy to factor, x squared plus bx plus c. You ask yourself, what do you multiply to get the constant that you add to get the middle coefficient? Okay, so when we have problems like this, x squared plus 7x plus 12, leading coefficient is 1, not perfect squares. Ignore that though. What can I multiply to get 12? Then I can add to get 7, x plus 3, x plus 4. And that's how that works. Okay, so any that we have like that would work in that way. Okay, you also want to be aware of signs when you're working with these, because you might have to put the negative where you place the positive and negatives, because we can have opposite signs. So if we had like x squared minus 12x plus 32, we know that both would have to be negative because we're multiplying to get a positive, but we're adding to get a negative. So just be aware of that. So we would have x minus 8, x minus 4. We can multiply negative 8 times negative 4 to get a positive 32. We add them to get the negative 12. You might have a situation where you have like x squared minus 3x minus 10. We know they have to be opposite signs. And because the middle term is negative, we'd have to make that 5 negative. Okay, our other possibility is where that leading coefficient is not 1. In this case, you would want to try trial and error first. And then if that did not work for you, you might want to, if you had to, do term splitting where you could group. Okay, so let's take a look at one like 21x squared plus 13x plus 2. This is a great one for trial and error because my last term is 2. 2 is prime. Its only integer factors are 1 in itself. So I know we've got a 1 and a 2. It's plus and plus, which makes it even easier because I'm multiplying to get a positive and adding to get a positive. So now this is where it's kind of like a math puzzle. I play around with it with the factors of 21 until this product plus this product gives me that middle term, okay? So if I put, let's see, 21, I got 3 and 7, I got 1 and 21. If I put a 3 here, this gives me 6x. I put a 7 here, that gives me 7x. 6 plus 7 is 13. I am done. Okay, and that is factoring using trial and error. That is the way I would prefer that you factor. If you do not remember how, or if you are not successful in that, there is a backup way of factoring. Just make sure you're very quick at this, where you multiply the first term times the last term. That gives us 42x squared. You ask yourself, what do you multiply to get 42? That you add to get 13. You would break this up into 6 and 7. Then you would do 4-term grouping here. Looking at the first group, you would take out a 3 and an x, and that would leave you with 7x plus 2. We want this to stay the same, so we have our 7x plus 2. You would factor out a positive 1, so then you would pull out what they have in common. You would group what's left, and we get the same answer after a lot of work. So those are our methods of factoring. Now, some of them may be a little more complex. For example, instead of having 2x squared, we might have 2x to the 4th, and then a minus 5x squared, and then minus 3. So this is a quartic that's in quadratic form. So we can actually still do guess and check, or trial and error, whatever you want to call it, but this time it's an x squared and an x squared. And then we need to multiply to get a negative 5. So if I make that a negative 3, that gives me a negative 6 and a positive 1, and I'm there. And that is completely factored over the set of integers. You'll notice on your homework, several of yours will continue to factor. Even more fun. So I hope you enjoy this. Hope this helped. And let's practice our factoring.